Okay, good morning, everyone. You're all very welcome to this Foresight webinar, looking at scaling storage solutions for a net zero energy mix. You're all very welcome. My name's Tiernan Phipps. I'm a conference producer here at Foresight Events, and we're really happy to be hosting this webinar as part of our Foresight webinar series, looking at some of the crucial tech and solutions leading the way in the net zero energy transition in the UK. Delighted today to be joined by 4 speakers. They are Professor Victor Becerra, who is a Professor of Power Systems Engineering at the University of Portsmouth. We'll be joined by Jason Howlett, CEO of the Energy Storage Association. We've got Mike Ryan, who's Business Development Manager at Constantine Energy, and then all being well, we should be joined by Clinton York, who's UK Operations Manager at Sound On New Energy. But as usual, teams, Clinton's just having some issues joining at the minute. Hopefully they should be resolved. So before we get started today, just a few facts to kind of set the scene. We see now that we've got 6.8 gigawatts of installed power, storage power there. We've got that's a 500% increase on 2020, and 1.4 gigawatts commissioned this year as well. So certainly progress there. We've also seen in the Clean Power 2030 Action Plan, they mentioned that 23 to 27 gigawatts of installed storage capacity will be needed for the net zero energy transition. So we can see there still a lot to do and a lot to discuss and a lot to get our teeth into today. So we're really happy to be adding to that conversation today as well, and really excited to get into some of these key issues and also successes, I hope, in this call today. Just a final quick note from me. As usual, these webinars, they are sponsored by the Foresight event. If you enjoy these conversations, if you want to discuss more in person, then I'd urge you to check that out. I'll be popping a link to the conference into the chat at the end. If you do fancy having a look at that and what we're covering in that conference, this and much more, then do check that out. But for now, that's enough of me. I'm delighted to welcome Professor Victor Becerra, who's going to set the scene for us this morning. So, Victor, I will hand over to you. The floor is yours.
Thank you so much, Tiernan. Good morning, everybody. My name is Victor Becerra. I am a professor in Power Systems Engineering at the University of Portsmouth in the south of England. It's an honor to open this session. As Tiernan indicated, I will try to set the scene for the webinar, if you bear with me for about 10 minutes. So first, I wanted to introduce grid-scale energy storage. By the way, I am assuming interested and informed audience, but not necessarily experts, okay? So grid-scale energy storage means large installations of devices that are connected directly to the electricity system, which absorb energy when it's plentiful and cheap, and deliver it back to the grid when the demand is high or when the renewables are low, for example. Okay. Now, these storage assets are essential for integrating variable renewables, including, for example, wind and solar power. They help turn intermittent generation into a more controllable resource. So they store excess energy at midday or during windy nights, easing congestion on transmission lines, as well as rapidly correcting imbalances in the grid to keep the system stable. When I say imbalances, I'm referring to imbalances between generation and demand. So there are essentially 2 types of energy storage: short and long duration. Okay. So short duration systems are dominated these days by lithium-ion batteries. Okay, they can respond within milliseconds and run for minutes to a few hours. Okay, so they're ideal for things like frequency control, voltage support, and shifting solar output from the day to the evening. There are also long duration options, such as pumped hydro, that can run for many hours or days, helping ride through extended low wind or low sun periods. It's important to have a healthy mix, okay? Fast batteries help stabilize the grid in real time, while long-term duration assets provide deep reserves that help support longer system stresses as well as provide interseasonal storage, okay? So how grid-connected storage make money? The companies that own these assets, how do they make money? They can make money in different ways. So, for example, grid operators pay battery asset owners to respond to short-term system imbalances. Okay, services like frequency response includes this. Okay, energy storage can also be used for arbitrage. This is storing energy when electricity prices are low and discharging this energy when they are higher. So they are sold at a higher price than the energy is bought. Okay, so that's arbitrage. Then by storing surplus output from variable renewables and then discharging this power later, energy storage systems can help balance the presence of these renewables in the grid. And there are ways of making money out of that as well. But we'll be discussing a little bit of that a bit later on. So I wanted to tell you about the different types of storage in the UK at the moment. So I will start with pumped hydro, okay, which is the oldest long-duration storage technology. It involves storing vast amounts of energy by pumping water from a higher reservoir when energy to a higher reservoir when energy is plentiful, and then releasing that water to a lower reservoir, which is like a lake, through a turbine when needed. There are facilities which are well known in Wales and Scotland, okay, that are capable of storing up to 9 gigawatt hours of energy. One is in Wales stores 9, the one in Scotland stores 7 gigawatt hours of energy. There are expansions that are planned in Scotland in particular. There is one called the Core Glass plant that is expected to be completed around 2030 and is designed to store up to 30 gigawatt hours of energy. So this will add significant reserves of energy to the grid. There is a drive by energy companies to develop new forms of long-duration storage, and this includes, for example, liquid air storage and hydrogen. These ways of storing energy are capable to perform interseasonal storage. Okay, so for example, solar energy collected during the summer months could be stored and released during the duller autumn and winter months. This is just an example of the use of this type of storage. So in liquid air plants, excess electricity is used to cool air to a liquid which can then be stored in insulated tanks. When electricity is then required, the liquid air is heated and turned into a gas again, and then that gas moves a turbine and electricity is generated. There is, for instance, a 50 megawatt liquid air plant that is planned to start operations near Manchester in 2026. In hydrogen storage plants, on the other hand, we have that surplus electricity powers a device called an electrolyzer that splits water molecules into hydrogen and oxygen. Hydrogen is then stored, and when electricity is needed, it is fed into a fuel cell or a turbine to generate electricity. An example of this type of facility is called the Albrook plant in East Georgia, which is expected to be in operation by 2030 and will have a storage capacity of around 320 gigawatt hours. So you can tell that they can be very large. This facility plans to use 3 repurposed salt caverns that were originally developed to store natural gas. In terms of batteries, we have Britain's largest grid-scale battery installation at least up to when I checked this earlier this year, is located in Wiltshire. It's called the Manatee Battery Storage Project. It was completed in 2022 and is capable of absorbing or delivering up to 150 megawatts of power, which is roughly equivalent to the demand of 450,000 UK households. The energy storage capacity of this facility is around 266 megawatt hours. Now, by 2023, the UK had a total of about 5 gigawatts of battery storage already in operation. The government ambition is to have up to 27 gigawatts by 2030. And there are currently, or at least when I checked earlier this year, currently projects totalizing around 59 gigawatts in the grid connection queue. However, this queue had become a bottleneck, and Ofgem and the network operators are reforming the rules of how connection rights are allocated to get the viable assets online in a faster way. So about the growth of renewables in the UK. We have that, and we know that the deployment of renewable energy in the UK, particularly offshore wind, has been a success story. But this sometimes stresses the grid in the sense that it may cause things like congestion. So when transmission capacity is full, we have that the electricity system operator often pays wind farms in Scotland to reduce their output if there is too much wind, and pay gas generators in the south to meet the demand, because there is no way of transmitting so much power to the south of the country, of the UK. So in the first 2 months of 2025, for example, this balancing and curtailment cost exceeded 250 million pounds. If there was adequate storage up north in Scotland, this could absorb that surplus instead of not generating it or wasting the opportunity to generate it, cutting both emissions and system costs. We have that the UK has a strong innovation ecosystem. We have some companies that represent that ecosystem here in this webinar. In the UK, there are developments of innovative battery chemistries, things like digital twins to model battery systems, AI-based fleet control systems for storage, as well as advanced monitoring systems. If we collocate storage with renewables, this is putting the storage near where the variable renewables are, this can reduce curtailment and delay grid upgrades, which can be costly. Repurposing infrastructure can be a good idea as well. For example, the case of the salt caverns I mentioned earlier. And this is particularly helpful for long duration storage. These approaches can help expand quickly while keeping system costs down. Now about the market and challenges with investment in energy storage. Now, technology is not necessarily the limiting factor, but economics and market design can be a limiting factor for this. Current revenue models may undervalue the full range of services that energy storage can deliver. So, for example, frequency response markets are short-term and they are saturated. We have that congestion relief and locational benefits of energy storage are not necessarily rewarded. We have that price arbitrage alone doesn't capture all the benefits that storage offers to the system. And we have that system resilience and capacity and are currently undercompensated. So the current market tends to favor short-term, fast response batteries over strategic long-term duration projects that the system increasingly needs. So we have that long-term duration projects which have high upfront costs, but only long-term benefits have problems. There is a need for more stable and predictable revenue streams, which are essential to unlock investment at scale. So we have that Ofgem the electricity regulator, NESO, the electricity system operator, and the Department for Energy Security and Net Zero are exploring new flexibility markets, locational prices, and longer-term contracts for low carbon flexibility. This will certainly favor the investment in long-term storage. Now, about planning. Scaling storage, deploying more and more storage requires strategic system planning. It is important to anticipate where renewables will connect, reinforce transmission in advance where possible, and place storage where it relieves congestion and supports local flexibility. We have that clear and consistent planning rules and long-term policy signals will help provide investors and developers with the certainty that they need. In addition to the use and benefits of storage I mentioned earlier, there are other benefits. For example, a grid that is rich in storage means fewer blackouts, okay? So the system is more reliable. There is less dependence on imported gas, and electricity prices are less volatile, so the energy bills are more predictable. We have that storage also underpins the electrification of heat and transport, which is critical to achieving net zero while protecting consumers from volatile fossil fuel prices. My closing remarks follow now. So if we want a reliable and affordable zero carbon electricity system, we have that storage, and this probably most experts agree with this, must grow in step with renewables. That requires faster and fairer grid access, suitable market mechanisms to pay for flexibility and resilience, as well as continued innovation in both technology and operation. With these in place, the UK will be in a good course to achieve its grid decarbonization targets by 2030. Thank you. That's the end of my introduction.
Professor Becerra, thank you very much indeed. I think that was really important to set the scene and see where we are in terms of storage in the UK right now. So very helpful. I'm sure that's stimulated a few questions. Please do feel free to pop them in the Q&A tab that you see at the top of your screen there throughout the session. I will make sure that they get to the speakers and get an answer. We'll move swiftly on then. Delighted to introduce Jason Howlett, who is Chief Executive of the newly formed Energy Storage Association. Jason, it's great to have you here. Really excited to hear about the work that the association is doing and will be doing in the next few months and years as you get going and yeah, get your operations in order. I'm sure you have already. Yeah, good to hear what's going on. So Jason, I'll hand over to you now.
Thanks, Tiernan, and thanks, Victor. Yeah, so the Energy Storage Association is really, well, a little bit about me for those that don't know me on the call. I've been in the sort of renewable sector for probably 15 years or so, started in pumped hydro. I started in biogas with anaerobic digestion, producing green biogas. Obviously, then we were burning that through combined heat and power. For operational facilities on sewage works, then into pumped hydro, then battery manufacturing, sort of moved into their solar distribution and back into battery manufacturing. So sort of covering various technologies from fiber, nickel, cadmium, lead acid, and then more through into the lithium ion, and then starting to explore newer technologies that are starting to also come through. One thing I really saw within the UK over the last couple of years was the real absence of cohesive policy and cohesive thinking around the energy storage sector. There's lots of sort of niche areas and individual areas, but there's nobody really looking at this. So probably 2 years ago, when I was the global CEO of Give Energy, I was getting together with a few people really starting to share the concept. And when I originally had a CEO in mind that was going to run this, who unfortunately wasn't able to take on that role, it came to the decision last year, back in December, when I thought, you know what, I'll just do it myself. So I resigned from Give Energy and left in March, and then really set up really working then with the people who'd given me strong indication that they wanted to get on board, and we had universities, manufacturers, energy companies, and we got a real collection of people together that was trying to represent a broad spectrum of education and theory through to the manufacturers and practice. So we launched in June with the aim of really representing the entire industry. So both, as Victor's been describing, all the sort of technologies and applications, from long duration, geologically based applications, all the way through behind the meter lithium ion in sort of residential and commercial industrial spaces. I think what's become really apparent is the massive gap that's been in long duration geological and behind the meter sort of residential and commercial. And this is where the association is really going to focus its attention. And this has been, even when we started articulating this with the likes of DESNZ and NISO and the new GB Energy, even before it was formally ratified, again, we were getting a lot of positive pull in the sense of, that's great because we've not actually had anywhere we can go to talk to about the industry. So it became a real no-brainer. And the number of people I've then spoke to afterwards have gone, well, why haven't we had this set up before? And it is a real surprise because, I've pushed for it in previous roles for other organisations to do this. But if nobody's going to do it, then we'll do it ourselves. So we've really set out now. We launched formally in June, July. And we've added a number of members since and continue to grow and continue to add members. We're representing an even broader spectrum now. We've got a lot of distributors on as members, more manufacturers, logistics companies, even the British Geological Survey have joined us recently, and more energy companies too. So we're really broadening that, and we've got more members to announce following the Solar and Storage Show the other week. So it's really gathering momentum now, and I think we're in this real strong place where we start to, and we've already been lobbying government hard in a few areas, and it was really interesting. Before we were even formally launched and publicly launched, I was representing the ESA at DESNZ events on interoperability and connectivity. But what we're seeing now is, as we approach next week our sort of first operational board meeting, is that we're going to start these working groups to focus on some real industry challenges. And what I'm really encouraged by is from our conversations that's been taking place over the past few months with government, is we're likely to see energy storage become a real part of the Warm Homes Plan. And energy poverty is something really close to my heart that we need to tackle and make sure that energy is affordable for all. And I think it's one of those things that starts to just make sense. You think this shouldn't be just left for those that can afford it. We've got to make sure that we're bringing everybody along with the technology advancements. So the Warm Homes Plan, which will probably be out in the next quarter, certainly before the end of the calendar year, I think is going to really start again to put that the technology at the heart of this. I think we're also seeing from the flexibility roadmap, which I was delighted to see. Again, we've been supporting that technology, that development, even in the latter stages, is the importance of batteries, as Victor was talking about, in terms of grid services, but in terms of also levelling up the supply and generation dilemma that we all know is there with renewables being intermittent in their generation, but obviously demand being pretty consistent, even though there are obviously variables during the day. We know that we've got to match those at all times. So it's really, really important that that flexibility roadmap delivers. But I think what we're also really keen to develop is things like the future home standards. And again, we've been obsessed by generation and adding batteries into that mix is really, really important, because we're just still building a problem. We're still adding more generation without actually thinking about how we store energy in the local neighbourhoods. I was really interested. I was talking to somebody just yesterday who was saying that they know somebody who's bought a house, a brand new house, no battery on the development, and they've been told if they want to add a battery to that site, they'll invalidate their warranty unless they wait 3 years, which is just ridiculous when you think of it in that sense. That, you know, people are being almost obstructed in adding storage because you know, and it just makes no sense. So we see these sort of areas of legislation and practicality. We see a big challenge still with awareness and raising awareness and how people get factual information and real, the ability to understand what is possible with an impartial advice. We see insurers still very, very nervous around the idea of batteries being stored on properties or in warehouses because of the sort of scare stories that have gone on. So there's a huge amount of awareness that the Trade Association is now embarking upon, and really bringing everybody's knowledge up and really driving those that legislation forward. So working with National Grid, NESO, GB Energy, we're engaged with all of these now, and we're really going to sort of represent the entire sector because, again, I was listening into a session yesterday. I think renewable energy generation and energy storage is just now a no-brainer. It just is the obvious thing. And I think still we're getting caught up with political thoughts of other parties saying, "Oh, we're going to scrap the Clean Power Act. We're going to undo all this." I think by the time we're even at a next election, this is going to just be so matter of fact and established. We've already seen clean power generation renewable generation is now the #1 generation source in the UK. But this is just a momentum that has to carry on. Now we just have to make sure we're shaping it and making sure energy storage is right at the heart of all of this.
Jason, thank you very much indeed. Really good to hear what's going on. I suppose a part of that as well will be speaking to the other trade associations. You know, I'm sure you're having conversations with Renewable UK and, you know, Solar UK and all the others involved in that space as well. I'm sure that's very important in order to develop a cohesive message to
absolutely
to government as well.
Absolutely. And this is what I talk about. You know, we're generation agnostic, and people have sort of talked about this. You know, with as long as it's green energy, if you like, clean energy, we don't care if it comes from hydro, from solar, from wind. We're just focused on how we're utilising that energy when it's abundant and deploying it when it's in shortage.
Yeah, absolutely. Good to hear. Thank you, Jason. I'll move swiftly on then. To Mike Ryan, Constantine Energy. Mike, you're very welcome. I think you may be the last speaker to speak today. I'm not seeing Clinton, so we will move on to the Q&A session after this. So do get your questions into the Q&A session, and once Mike has spoken, we'll move on. So Mike, over to you. You're very welcome.
Great, thanks, Tiernan. Great to be here. So yeah, Mike Ryan, Commercial Director at Constantine Energy Storage. Constantine Energy Storage is an investment platform focusing on GB utility scale battery storage. We're constructing about 1.1 gigawatts of storage sites across GB. We've got 3 currently live and a further 15 sites in various stages of construction. So clearly a big play for us. We've been going for about 4 years now as an investment platform itself. Very quickly touch on my background. So I've been in the industry for 19 years now. Worked in GB system operation, worked in markets, run a couple of energy trading teams. I'm actually a power systems engineer by training. Unfortunately, I went to the University of Southampton, not Portsmouth, I'm afraid, Victor. So a little bit of rivalry there, maybe. And then eventually, having gone through development, moved into the investment side. And I think for me, one of the really interesting areas around energy storage, and Victor touched on this, is that mix of the technical complexity, but also the commercial complexity of these assets, trying to construct markets and revenue streams that make them an investable proposition. Because you can have the greatest technology in the world, you can have a technology that solves all your problems, but if there's no way to monetize that in a form that investors are comfortable with, then ultimately the technology doesn't get deployed. Now, I say in GB, actually, we've been relatively good at that, certainly on short duration storage. It's why we have an investment fund looking at battery storage and deploying money into that. But it is still very difficult to do on the long duration storage side. We don't mind what storage technology we invest in as long as it's investable. And to date, that's only been short duration battery storage for us. Now, so the government's recently come out with its long duration energy storage cap and floor scheme. Even that, we would say, doesn't provide the kind of level of certainty that you'd hope to get the volume of long duration storage that the system needs deployed onto. It makes it a more investable proposition, but not more investable than other markets, other technologies, other areas that are all competing for that same capital. And that's really the challenge. It's not, oh, does this make a return that somebody might accept? It's, does this make a return that outcompetes the return that other technologies, other pools on capital out there are offering? I think the other area where perhaps government has missed a trick on long duration is in my view, and somewhat in our view, they've probably defined long duration as too short. We don't believe there is a gap in the 8-hour storage market. We think the gap is actually in that kind of daily and longer weekly seasonal storage piece, and trying to incentivize 8-hour storage probably is trying to solve a problem that doesn't really exist. Battery storage is pushing up towards 4 hours anyway, purely on merchant basis and just the cost reductions in the technology. You could see a world where it would slowly trend towards 6, maybe 8 on its own merits. But by setting the long duration storage sort of entry at 8 hours, what's been incentivized is a lot of 8-hour storage projects to be built or to bid in for it, and not a lot of multi-day or seasonal storage sites to be built. So in our view, that's the area that's still missing, the area that we still really struggle to make an investment case for. And my view, perhaps somewhat controversially, is I think we also need to take a long, hard look at just how much it would cost to get that final 1%, that final 0.5% of carbon off the system. And if we are truly focusing on a net zero economy, do we want to spend all our time, effort, and money trying to get that last 1 or 0.5% out of the energy system when it could be spent more effectively getting another 1.5% out of transport, out of heat, out of shipping, out of flight? So that's an area where I think government isn't being joined up enough in how we're thinking about energy storage. The other thing I would add, that again was brought up earlier, that I 100% agree with, is there is no one silver bullet here. We absolutely need a mix of technologies, and that includes a mix of storage technologies. Whilst our primary investment focus today is batteries, that doesn't mean that we think batteries solve all the problems on the system. They don't. They are very good at a lot of things, but there are some things that they're not very good at. And we do need to make sure that we've got an appropriate mix of technologies out there so that we can ensure that we're operating the system safely, securely, managing constraints where possible. The other concern we have, I feel like I'm just flagging concerns here, around government targets on how much storage they want to deploy, is just the pace at which we can physically deploy storage or energy technology of any kind. As was mentioned earlier, 1.4 gigawatts got deployed in 2025. Now that 1.4 gigawatts was deployed with the energy system, and by that I mean contractors, manufacturers, investors, NESO themselves, NGET, so National Grid Transmission, all pretty much working flat out at deploying the most amount it's possible to deploy in 1 year. Now, to try and hit 20, 30 gigawatts in the next 4, 5, 6 years, we're going to have to deploy technology at a much faster rate than we're currently able to. And for me, the big concern is we're not building up our supply chains. We're not building up our workforce. We're not building up our competencies in being able to deliver the technology at that sort of rate. And certainly we see from our side, and most other investors that we speak to see, that actually the speed of deployment and the ability to work at pace as being the biggest threat to hitting the sort of targets we're aiming for. The technology's there. Markets, they can be improved, but there's enough value in it for people to be interested in investing. But the big thing that's putting people off at the moment is just the timescales it takes to invest. The queue management that's going on at the moment, so that a lot of assets stuck in this connection queue. The issue there isn't so much that there's 50 gigawatts in a connection queue when there's only 20, 30 gigawatts required. It's that the people with the capital who are willing to deploy are probably stuck towards the end of the queue. So they're saying, I've got the money, I've got the technology, I want to build a site, but if you're saying I cannot deploy it for another 5, 6, 7 years, then I'm going to move on and deploy my money elsewhere. So on the plus side, I think we have the markets, we do have the technology we need. I'm just concerned about our ability to deploy it at the sort of pace we need to. And we have to bear in mind that pretty much the entire world is trying to do the same thing at the same time. So there is a huge draw on this one pool of resource, of skill, and of capital. For an industry, it means we're in a really positive place because it's never been as exciting and as fast growing and doing as much as it is now. But unfortunately, we still need to do a hell of a lot more to hit the sort of targets we're aiming for.
Mike, thank you very much. Really good to hear that perspective as well on some of the challenges. I think, if we don't address them, then we don't know what needs addressing. I think it's important to hear it kind of from the horse's mouth as well. So thank you very much for that. Really, really interesting. Okay, let's get into some questions then now. I am seeing one in the chat here, and I think it's really interesting. It goes to the heart of what all three of you really were speaking about, and it's kind of around funding as well. So Andy McNeil asks, he says, many thanks for an informative webinar. It seems to me that the UK has a disjointed approach to adding renewable generation capacity via allocation rounds and building out required long duration inter-seasonal storage. So Andy asks, do the panel have any views on whether it might make sense to integrate storage into the allocation round process, in effect require developers to propose dispatchable power schemes combining generation and storage rather than perpetuate technical, operational and commercial complexities created by this disjointed approach? Any thoughts on that?
Well, yeah, I mean, I'll certainly have my 2 pence worth here. It's definitely, I think co-location is now more and more being discussed when you think about renewable generation and grid connections, and then still being limited. Well, we've got to think more holistically in providing a solution from the renewable generation, as opposed to here's more generation, the grid will deal with it, and somebody else will deal with what we do with that energy. So I've been detecting a lot more conversations, and I'd be interested in Mike's obviously view from the investment particularly. But I think co-location of short duration, still short duration with electrical energy, or sort of more flow batteries as we start to think about of the emerging technologies here. But for me, it just has to be brought hand in hand.
Thanks, Jason.
Yeah.
Mike?
Yeah, more than happy to give my thoughts on that. I'll try and answer both. So on bringing it into the allocation rounds, that's something that we would have said would have been a very sensible thing to do at the start. But my view is that ship's sailed, because now you have so many connection agreements out there, so many people who've gone through planning, so many people who started developing sites, that to try and unwind that and say, actually, now we're going to do storage. And I'm talking more about short duration storage here, because that's what's currently exists. To try and do that through the allocation round, you're going to then effectively say we're either going to unpick or no longer guarantee those connections that have already been awarded. So we're almost too far down a line to try and rein that back. Could you get more by going through the allocation rounds and focusing more on co-location? You could. My question would be, but will it happen faster? Because if what's going to happen faster is the stuff that's already got connection agreements and is out there trying to deploy, then whilst it may have, at the end looking back, have been more efficient to do it through allocation rounds, we might get it faster through just proceeding with what it is we're doing today. In terms of co-locating, again, co-location is something we look at. We haven't co-located any of our sites at the moment. That's more for an investment reason than it is a technical reason. Returns on battery storage sites are higher than they are on solar. So if you're building a battery storage site and then say, do you know what, I'm going to stick solar on, well, all you're actually doing is bringing down your overall return. So it doesn't normally make sense to do it, particularly because you've got comfortable with the risk of a battery storage investment. The other way around actually can work quite well. If you're saying I've invested in solar and I've got space for a small battery, well, the battery just ups the return slightly on my solar project, and actually I'm not taking on that much more risk adding a small battery to a solar site. So it's an important, although it can seem minor, distinction between what's your starting investment thesis. The other challenge that's been there for a long time but is finally being resolved is very technical and very boring, and to do with compliance and metering obligations and regulations when you try and co-locate sites. It's quite hard, if not impossible, to bid into certain grid services if you start co-locating sites. It's quite hard to trade certain products if you start co-locating sites, and it's taken a long time to try and resolve some of those, what are essentially policy, regulatory, code issues to enable co-located sites to actually operate to the same level that two separate sites would be able to.
That's interesting. Thanks, Mike. Victor, have you got anything to add on that?
Yeah, I agree. In an ideal world, yes, co-location is a great idea. In practice, and I'll illustrate this with an example. I visited a solar farm once in the south of England that has a battery storage system on site, grid scale battery storage system. And instead of operating this storage system in support of the solar farm, the owner operates it to provide frequency response services to the grid. So although it provides a benefit, it's not necessarily, I mean, this could happen if the storage was elsewhere, okay? It doesn't need to be co-located for it to be used in that way. So yes, as you say, yeah, maybe the regulations are not ready, or even the market is not ready for, achieving the potential benefits that could be achieved with co-location. But in an ideal world, yes, it would be great for that to happen. It would simplify things.
Mm-hmm. Thanks, Victor. Another question here, it's for yourself. I think it's for you, Mike, from Tom Robinson from the Advanced Manufacturing Research Centre in Sheffield. Tom asks, what are the challenges currently limiting this pace of deployment that you speak about? If it's not investment, it's not technical. Are there any limitations in the manufacturing processes which need to solving to increase lead times?
So if you'd asked me probably 18 months ago, 2 years ago, I'd have said yes, lead times were one of the big issues. A lot of that was around basically a hangover from COVID, and then what happened with Ukraine causing just issues in supply chains. And it's kind of, it's rolled on. It's always been a different product that was the thing setting that long lead time. So it was transformers, then it was IGBTs, then it was inverters, and then it was SCADA. So, but actually a lot of it on the supply of physical kit side has either largely been resolved, or we've all got to a place where we understand what the kind of new normal for lead times is, and we're able to deal with that. The big restriction on actually pace of deployment is, in lots of ways, the simplest one. It's people. we really struggle to have the number of people that we need to build this stuff, because some of it's highly skilled and we're trying to build a lot. And it's not just the energy system that's calling on these people. You know, it's not just storage. We're trying to build a lot of solar. We're trying to build a lot of wind. Oh, and we're trying to build a lot of data centers. You know, oh, and we're building Hinkley that's taking up 12,500 people, you know, trying to construct that. And Sizewell will do the same. HS2 is calling on lots of resource. So it's, you know, civil contractors, as well as your M&E contractors, as well as SCADA engineers, as well as senior authorized persons, commissioning engineers. It's all this skill set that unfortunately there's been an absolute dearth in training. There's an absolute dearth of skilled engineers. I'm hoping Victor's courses were absolutely full to the brim at Portsmouth with people wanting to be power system engineers, but I know when I was there, unfortunately, that wasn't the case. And even fewer who did the degrees then went on into the power systems engineering or the energy industry. And that's biting us, that is hitting us hard now,
Yes.
because we're trying to deploy at a rate we have never done before in the history of an energy system.
Victor, any thoughts on that from the university perspective? And also alongside that people power, you know, you mentioned this kind of increase in digital solutions as well around, you know, modeling and digital twins and AI and things like this. Is that something that could be a bit of a reliever alongside this obviously needed influx in people power as well? Any thoughts?
Yeah, obviously we are trying to do our best to offer the right courses to help industry fill those gaps in skills that currently exist and have persisted over the years. At my university, we have offered now for a few years a degree program in renewable energy, which is growing in size, and it's been reasonably successful and has had funding from the government to equip very good labs and so on. It's always a struggle to convince young people to join. And that is one of the key issues to convince them that there is a market out there and there is an urgent need for people with those skills. We are also opening in the coming year a new degree program on power systems engineering. And this is an undergraduate program, and again, we're hoping that it will be popular, but it's a similar struggle. It's not necessarily the most the best known program in engineering, let's say. There are other specialties that are better known and which tend to attract more people. But we know that the gap exists, and companies are eager to recruit more and more engineers in this area. So we're trying to address that gap that exists. Now, in terms of digital technologies, indeed, I mean, this is really important for the decarbonization of the grid in general, including the deployment and management of energy storage systems. We are doing research in the area, and we have been doing it for a while. And it really is important, and it needs to be further developed to match the needs of industry. But we certainly want energy storage systems that are reliable, that are predictable, and whose degradation, in the case of batteries, for example, can be predicted and understood as they operate. And this is something that is of high interest to us as researchers.
Yeah, thanks, Victor. Jason, I'd like to bring you in there as well. You know, we hear this so often around workforce challenges and things like that. Is that something that's on your remit? Is that something that you're looking at as one of your priorities? Do you think it should be? And also, just really quickly, if I can test your brain, there's a question in the chat here for you as well. How are you engaging with dispatchable power producers / technologies, primarily peaker plants, to understand the future interplay between storage and dispatchable power? So if I can give you two there, if you can balance them.
Yeah, sure. No, definitely. I did a podcast last week, actually filmed one that's not out yet, but we spoke a lot. And this is one of the other passions of mine is education and inspiring young people particularly to think about this, but I think there's also this space and this sector. So I do a lot of work with a sort of charity called Primary Engineer, which is tackling and trying to get primary school children engaged in STEM and engineering. I think this question so far been answered from I guess from a degree based, and the conversation I was having last week on this podcast was very much about the physical hands-on people who are doing this that don't necessarily have a degree, but they've got the apprenticeship. And thinking about the apprenticeships here, and we had a very good discussion in the sense of how do we get quality apprenticeships, and how does government really get behind supporting companies to take on apprentices rather than the mass approach that was tried previously, where these companies were set up to deliver apprenticeships but didn't actually probably deliver the outcomes that were needed. I think it's massively important that we start to think about how we really develop this space, and it is an area of personal passion of mine, and it's in amongst all those priorities. It'll be interesting next week when the board comes, if that's when we have our board meeting, how that sort of features, because I think it's certainly a personal interest of mine how we engage with government in this space. I think this is the interesting challenge for us all here is there's probably so many things we've got to tackle. And I've talked about this. I think we're moving probably faster in this space than we've ever moved. Legislation is coming out faster than it's probably ever done. And we see more and more consultations happening right now. And this is why it's massively important as we're trying to scale. And I've got new people starting in the association, is to try and engage on more and more fronts and really represent the industry in these spaces, because the physical supply chains, probably other than some of the grid scale challenges, but from physical storage itself in terms of lithium batteries, we've got no issue, even though the rest of the world is going, the pricing's come down because we've got oversupply at the moment as manufacturers have scaled. I think what's really interesting is how we deploy other technologies too and widen our supply chain risk, because we're heavily reliant on Asia and China for a lot of our infrastructure at the moment. So as we advance other technologies, pump storage, geologically based technologies, flow batteries, some great work going on in the UK, thermal storage. There's a huge range of technologies we need to think about here that have different supply chains, and that de-risks that overall concept. And I think this comes back into then the second part of your question is, as we look to deploy a wider range of technologies that actually can meet that instantaneous need. I mean, electrical storage is obviously the batteries operate within milliseconds of providing demand. But for me, the broader the range of technologies that we have, then the better suited we are, and we de-risk our approach to what we're doing.
Thank you, Jason. Very comprehensive answer there. And well done for keeping them both in your head as well, linking them very well. Impressive. Another question here then from Aoife Parker. Aoife asks, do the panel have any views on how emerging technologies discussed can enable the UK system to more proactively harness demand-side flexibility as a credible mechanism for stabilizing our future energy system? Are there any key blockers we need to remove? So kind of moving the focus there to demand side. Any thoughts there?
I think it kind of links into what I was just talking about there with the technologies and what I referenced in my opening piece. The interoperability here is massively important, of assets all working together. We've got to have greater ability to work in that virtual power plant, the VPP that everyone keeps talking about, and linking these assets. And there's a huge amount of work going on within DESNZ at the minute on interoperability. The one area that I think is lagging is the cybersecurity side of this. We've got NISO, who've just published a paper that we were consulted on. We've got DESNZ working on it for 2027. A bit like Mike talked about in the finance piece, I think the horse will have bolted before we'll have deployed a huge amount of assets without really protecting from potential state interference. I've been lobbying this for a couple of years or more. You can see what's coming. We're going to create huge interoperable assets, and we've all seen what's been happening with cyber attacks. Our grid becomes incredibly vulnerable if we don't take the right necessary actions. But again, if we deploy a mix of technologies, if we've got huge reserves of pump storage, if we've got huge reserves of electrical, heat storage, green hydrogen storage, we start to de-risk from that element. But the interoperability in cybersecurity is definitely one of those elements that links together into the flexibility roadmap that was published a couple of months ago. I think that sets out what we're trying to achieve as a country. The framework is there. I'm really excited by that. My caveat is we've got to accelerate cybersecurity into that piece.
That's an interesting point. Thanks, Jason. Victor or Mike, any thoughts or any additions on that?
Probably just expanding a little, I guess. I think a lot of the technology we need is there. I think it's absolutely crazy that we're not mandating most of that technology being stored on all new builds, because that's a hell of a lot cheaper than trying to retrofit it. The fact that we got as far as where you can have an EV charger, but that's all we're going to mandate is ridiculous. It should just all be installed. I think we still haven't cracked this problem, though, of if you've got capital and element of wealth, you can afford to install all this technology and you will see your bills absolutely plummet. And if it's in a house you're going to stay in for 20, 30 years, or you're going to leave it to relatives, then that all makes sense. But if you don't have that capital, or it's a house you're not planning on staying in for very long, then it's very hard to make any kind of business case, personal business case, as to why I should spend thousands of pounds installing solar, installing batteries, etc. The impact on your energy bills is not enough to offset something in a very short space of time. So I think more work needs to be done on that. I think now actually might be an opportune time, because there's so much talk around, do we reform stamp duty, do we reform property taxes? I think there would be a fantastic opportunity to link in, well, what sort of tech do you have in your house? And if it's a greenhouse, then maybe you do get lower taxes, lower stamp duty, etc. I think there's things we could do there that could well be progressive rather than regressive in taxation, whilst also encouraging the sort of uptake we want to see. And I think those are more the actual blockers than it is the tech right now.
Thanks, Mike. Final question that I can see in the chat or the Q&A then, from Phil Dixon. Phil says, DEFRA are currently consulting on the possibility of including grid scale battery energy storage in the environmental permitting regulations. Is the sector in a place where it fully understands its risk to the environment and human receptors and factoring that into their bills, or does more work need to be done in this area? Anyone want to take that?
I'm happy kicking off. You can always do more work, right? There's always another study that can be done. There's always more research that can be undertaken. But I actually think we're in a pretty good place where we are, certainly again on the lithium ion side. Probably going to be quite unusual for me to say this, or you might find it quite strange. There's been a couple of fires recently in BESS systems in GB. They've been public, you can find out about them. In a very strange way, that's actually been quite good for the sector, because what it's shown is the systems and the processes that are in place work, and what we expect to happen happened. And residual water runoff, things like plume analysis that was done, has all actually proven its value, and there was no unexpected consequence of those incidents. Now, obviously, nobody ever wants that to happen, but the fact that it did happen, plans were enacted, and that all worked, I think is quite reassuring. One of the very sort of easy things you can point to that shows that, oh, actually, this must be working, insurance premiums are coming down, because insurers are going, actually, the risk here isn't what we thought it was. Actually, these things are pretty safe when as long as they're well managed and well looked after, and you've got the right plans in place. So on the large stuff, on the grid scale stuff, I think we're pretty good. Doesn't mean we don't have concerns about DEFRA's consultation and what it might mean they put into those environmental planning and permitting regs, because anything they put in is highly likely to be retrospective, and if it's retrospective on some sites, that could cause those sites to just be unviable because you wouldn't be able to do it, and it might shut some sites down. So there's a little bit of nervousness there just about making sure that DEFRA is using the absolute latest information and research about these systems. I think actually a lot more concern comes from when you're going to the smaller scale and you are looking at domestic, and I think a lot of that really stems from the issues that have been seen with, PEVs, these portable electric devices, vehicles that have had a number of issues, largely because, let's be frank, they're being brought from manufacturers who are manufacturing them to no sort of level of international or British standard, and they're being brought over here on the cheap. And they're just not good quality and they're not safe. And so I think the psyche around storage is very much linked to actually another industry that we're not really connected to, but we're getting the blowback from it. I think we have to be very wary of that, because you don't want the entire potential domestic industry pulled down by something that isn't actually anything to do with energy storage.
Thanks, Mike. Very comprehensive answer. And we're at time then. I'm wondering if we can finish by just a final question from myself. If all of our speakers could maybe give a final word or two on, kind of, so myself and Victor mentioned this around the huge increase in capacity that's needed according to Clean Power 2030 in battery storage. And we've seen, I think we've reached £500 million in curtailment costs this year alone. It's huge. Fast forwarding to 2030 and then 2035 and 2050, then what does success look like, and what will we regret not fixing sooner or not fixing now in order to get there? Any final thoughts there? Victor, I'm wondering if we can start with yourself, put you on the spot.
Well, yes, success in this case obviously means that the targets for storage have been met in 5 years. It's looking increasingly short in that period of time. There are plenty of things that still need to be resolved. So again, to achieve those targets, all those issues related to permitting, regulations and so on, as well as markets, will need to be resolved in time for deployments to happen. Supply chains need to be robust and strong enough to deliver what's needed. I think perhaps the main worry is achieving what is needed in terms of long duration storage, which is very large, and we are far off from those targets. And there is a lot of, as was mentioned in this webinar, uncertainty in relation to the value proposition that is needed for that long duration storage to be deployed as required. So again, success in that area would mean enabling that value proposition to be in place so that the deployments can happen in time. But as I said, time is running. It may be still possible to achieve those targets, but a lot of good things will need to happen in a very short time.
Thank you, Victor. Jason, final word.
Yeah, echoing some of the points from Victor. I think obviously achieving the target and probably hopefully even exceeding it, but with a real mix of technologies. So I think long duration is going to be the hardest to achieve, because just pure timescales, if you're going to put pump storage in, it's not as quick as deploying a gigawatt of batteries. So that is definitely there. I think the biggest challenge and the biggest thing we'll regret is not tackling future home standards, and also the cybersecurity, as I've mentioned before.
Yeah. Thanks, Jason. And finally, Mike.
So for me, it's a much greener, much cleaner system at a price that the end consumer feels is fair, and ties straight into the blocks for that. I would be two. It's our ability to actually deliver it in a timescale where it has a meaningful impact on prices, and also what are we doing about the long duration storage problem. And I'm also, like I say, probably slightly different. I don't mind if we solve it with storage, or we end up saying we'll accept a small percentage of carbon and we'll keep some strategic reserve if that's what we have to do. But if we ignore it and we let stuff shut down and have no storage, then there are going to be years where prices are going to be incredibly expensive, and that really worries me.
Yeah, thanks, Mike. It's an interesting point there. Well, I think that's a good place to leave it as well. Thank you so much to all of our speakers. I thought it was a really interesting discussion. It covered a lot of ground there, so thank you very much. Just a note to everyone that this is recorded and will be sent around to you all post conference. You won't be able to access it straight away. We just need to do some things on our end in order to make it available. So check your emails. That should come out in the afternoon today as well. But with that, I'll say thank you very much again to all of our speakers. Thank you for joining us from the floor and for your very interesting questions. We do hope to see you again at our future webinar series. And with that, I'll say thanks again and enjoy the rest of your week and weekend when it comes. Thank you, everyone. Take care.
Thank you.
Thank you.